Good morning, everybody. I see everybody's still finding their seats, so I'll just wait for a few more seconds until everybody is seated, and then we can get started. All right. So I am Donny Wals. I am an iOS engineer at a company called Disney Streaming Services. You can find me on Twitter with @DonnyWals. You can read stuff that I write on my blog at donnywals.com. My spare time, I love to try and play my guitar, learn new stuff, share knowledge, that kind of stuff. Today I would like to tell you a little bit about something that I really like to do at work, because I work on a framework, an SDK, where I don't have any UI to test my code with. So what I really like to do is TDD, or some variation on that. So I would like to share with you what I have learned to try and learn how to adopt test-driven development in the workplace. Before I do that, I want to share with you the whole process of how to even get to the point of writing proper tests. So this quote right here, that might look familiar to you. I know it does to me. When I started developing, I used to get the question from managers, from colleagues, like, hey, does this feature work? Does this form work? Does this page do what it's supposed to do? And my response usually was, yes, I think so, or I think this feature works. The reason I would always say I think it works is because maybe I tested it last week for the last time, or I just simply haven't seen it fail yet, so, well, I guess it's fine. And I never really liked that. I always wanted to be able to say, I know this works. I know for a fact that this code here is fine. I know that we talked about this, we decided that it should work like that, and I know it works exactly like we intended to. So I found that not knowing if your stuff works is usually a result of simply not having tests and not writing them. So my goal today is to help you also know that things work, and I want you to understand how you can build a quality test suite. I also want you to learn how you can start to test in existing projects. Most of us decide we need tests at the point where a project is well underway, and we figure out that we actually have no idea what we're doing, and a few automated tests would probably help. So I want to show you an approach that you can take to have your existing project and add tests to it, rather than asking for a complete refactor of everything without building new features. I also want to try and show you that a good test suite does not cost a lot of extra development time, if any at all. A lot of time you'll find that once you have decided you want to write tests, you want to figure out how it works exactly, and then you ask your manager for that extra couple of days to write tests for a feature, and they kind of decide that it's probably not worth it. I hope to show today that you don't need those extra couple of days. Before I show all this, let's zoom out a little bit more and figure out what to do before we write tests. Because before you write tests, you must gather requirements. If you don't have requirements, even if you are not testing anything at all, you are flying blind. If I tell you, build me an onboarding flow, that could mean anything. You're going to ask me, what pages are in onboarding? What is the purpose of the whole thing? What can a user do, and what can they not do? So gathering requirements is, even if you're not testing, very important to do. So how do you do this? How do you take something abstract or something vague or ambiguous, and how do you get proper requirements out of this? Well, step one I've found is go find stakeholders and talk to them. So who are your stakeholders? It's not the people who bought shares in the company. You don't talk to them usually. It's usually pretty much anybody who can and will talk to you about the product. So this can be users. Maybe you have a user focus group going on, and you're trying to figure out if something works. Talk to them, ask questions, figure out what they need from a certain feature or part of your product. Or talk to your project manager, talk to your designers, maybe try and get the CEO involved and ask them, what is the purpose of what we are building here, and how can we make that really good? What are the requirements to make this succeed according to you? When you have these conversations, it's unlikely that they will be clear and concise. They will not tell you, this. They will usually go off in a huge speech and tell you all kinds of stuff you're not really interested in. So expect a lot of ambiguity to also come from like your stakeholder conversations. And what's important here as well is try to understand what they want and what they need, rather than taking their literal conversation and translating that into a requirement. Often a stakeholder or a designer or somebody who is not technical will not really think about like what are the technical implications of this. They will just tell you, I want to get from A to B and I want to do it as soon as possible. And then it's up to you to figure out like, how do you do this? You shouldn't have to do this alone though. Your product owners, project managers, whoever you have should help you out because it's also in their best interest to know what they are making you work on. Like if they don't understand what we're building, how can you and how can they plan everything? So once you've done this, you have all the stakeholders, you had a little chat with them, you came up with a lot of requirements and conditions for the thing to be built. You're going to formalize these decisions. So what it means is you're just going to write everything down. Every business rule, every decision that you made together with the stakeholders, you need to write this down somewhere. It doesn't have to be a 20-page document. It can be a bullet point list. But this will be the foundation for your tests later, but also your foundation for showing that you are done with the work and that it was done well. So for every business rule you require and determine, also look for edge cases. Often when you talk to a stakeholder, they will only talk about the happy flow. Like if they want you to build a registration form, they will tell you that a user will always fill out everything. They will always have all the information asked and everything will go perfectly well. When, let's say, the requirement is to fill out an address, you might want to ask yourself, like, do we actually need this address? And what would happen if somebody just doesn't have an address? Like, not everybody lives somewhere. There could be people using your product that don't have a home. Like, are they not allowed to use your app? Do you really need an address? Like, these are cases that often a stakeholder won't think about, but you, as a developer who's going to test everything, you want to think about this stuff. Like, is it valid to leave things empty or to omit certain information? Now, when you formalize everything, a language framework like Gherkin is very helpful. I will talk about Gherkin more. For now, I'll just say that it's a human-readable way to communicate requirements in a product. But don't worry about that. We'll get to Gherkin. So once you have formalized your decisions and everything is written down somewhere, establish some acceptance criteria. You really kind of already did this, but you want to go to your stakeholders or go to your manager, show them your list of things that you are going to implement and make sure work, and ask them, like, if I have done this, like, am I finished? Like, is this the product we are building or the feature we're working on? And hopefully they will say yes. And then your next question, and I found this one to be very interesting, is when I ship this, when I send this to you, what are you going to do to it? Like, if you're building a form, what are you going to put in that form? If you're building a flow of something, what are you going to tap on? And this is not so you can trick your boss into thinking everything works. This is to find out if you really understood what they wanted and also if they understood what they wanted. Because sometimes, let's say you're building a phone number input, you can come up with 10 different ways to get a valid phone number. And somebody who's going to test your app will find the 11th valid way. So ask them, what are you going to put in? Maybe you missed a case. And based on this, you're going to refine your Gherkin requirements. The last step in gathering your requirements is to review and refine. So what this means is that you're going to do a final check to see if everything is covered. Do you really have all the edge cases that you want to have? Do you really have everything that's needed? Also check that errors are handled appropriately. Again, when a stakeholder or a designer designs something, they will usually think about the happy path. We have to come up with the unhappy paths. And make sure that everything that you write down in Gherkin is unambiguous. If you would have a description of a feature and you say, when I make an API call, it should work, that is a horrible description. It means nothing. What is it should work? You're trying to define that bit very specifically. So to recap, requirements phase. First, talk to the stakeholders. Figure out what they want, figure out what they need. Formalize the decisions that you have made together. Your stakeholders might not be super interested in a big document. Try to write bullet points. It doesn't have to be a huge thing. Third, establish the acceptance criteria and figure out what tests will be run by humans on your product, because you can also automate those tests later. And lastly, review and refine. You're never completely done. You can always do better, so keep iterating on everything. And also, this sounds like this process will take a very, very long time because there's many steps, but you can do this in pretty much an afternoon or something. Just sit down with people, talk, write things down, show it, have a conversation about it, and by the end of the afternoon, you will have a decent list of requirements written down. So a tool to write down these requirements, I promised I would talk about, is Gherkin, for instance. Now, Gherkin is a human-readable language to define behavior. And before I explain more about it, I want to show you what it looks like. So just go ahead and read this for a little bit. Now, I'm pretty sure that even though you have no idea what Gherkin is maybe, you understand this. And that's the beauty of it. The words in purple are important keywords in Gherkin, so I'll just go over those for you real quick. The first keyword we can see is feature. Now, what feature does, it provides a high-level overview of a software feature. In this case, logging in. Very simple, concise. This is what we're testing. Then we have a scenario. A scenario is a brief description of the flow or thing you're trying to test. In this case, it's attempting to log in without filling out credentials. Then we have a given. This is the initial state of your test. It's the initial state of the system. In this case, all we have is a login screen. There's nothing in the form, there's nothing special, it's just a form that allows you to log in. The next keyword, when. This is a change in the system that you're testing. It's always a single action. What's really important here is that you do not list several actions. So for instance, saying attempting to log in, getting an error, then correcting the error, and trying to log in again, that is too much actions. Everything before that attempting to log in again should be your given or your scenario. So when is a single action? Lastly, there's the then. Then checks that the system is now in a state that we expect. Right? So we have a given, what is the condition of the system now? We have a when, what are we doing with or to the system? And then we have a then, what is the outcome of this action? So now that we know what Gherkin is, and it can be this simple, why is this good? Like, why do I really believe that this is the best way to get into testing? And one reason is that Gherkin really gives you this solid foundation. It gives you a couple of simple rules. It is human-readable language. If you show this to a designer or a completely non-technical person, they will at least understand that there is something happening and they can read it and say like, no, this is not correct, or say like, this is correct. And hopefully they can even write a couple, like they can help you write more Gherkins. What I also like and experience is that this leads to a very good understanding of the system. So why is that? Well, if you start writing down these very focused and detailed test cases, what you'll find is that it becomes very easy to think, hey, but what if my input is not valid? Or what if this thing is going to throw an error? Because you're working on such a small level, it becomes very easy to think like with one or two options instead of having to think about the whole system all at once. And this makes it easier to discover like missed cases or edge cases. While writing this down, it becomes very easy to just add extra test cases. Since you're not coding yet, you don't see that something could maybe be a lot of work. So you can just start writing stuff down, and often you'll find something that you hadn't thought of before. So with something that's good, there's usually also something about that good thing that's less good. And there are, of course, pitfalls with Gherkins, just like with anything else. I have found that it's not always easy to get stakeholder buy-in. Not everybody is interested in working like this. Not everybody is interested in working on this. What I did myself is just keep doing it. Just even if everybody ignores you, just keep writing them and keep sending them to the people on your team, keep sending them to others. And you'll find that at some point they will see value in it. They will realize that you are now developing stuff faster, you're writing less bugs, and they, for some reason, magically knew a lot of things about the system that they would not have known otherwise, because they hopefully actually read your emails. Also, don't assume that what you wrote down is complete. You are going to write your tests and find out that you missed things. You are still going to have bugs. There's no way that you're going to be 100% bug-free all of the time. You'll have to accept that and just refine and review all the time to make sure that you are as complete as you can be at any time. And also, don't take this whole phase up until now with the whole requirements thing too literally. If sometimes you have to take a shortcut, or if sometimes it doesn't make sense to do things like step for step for step, that's fine. Like, of course, it's best if you can do everything step by step, but sometimes time pressure is real, sometimes you just need to get something done. And then shortcuts can always be implemented. Another one is that if you limit yourself to what you talked about with your stakeholders, is that they do not concern themselves with the technical details of your system. If they, for instance, are telling you to build something where you're pulling data from an API and syncing it in a cache locally, they will often just tell you, like, I want this thing to work well offline, period. Just, I have no internet connection. If I loaded the data before, it has to be there. And now it's up to you to figure out, what does that mean? Do I write something to a database? Do I use core data? Do I use Realm? Maybe just a file, or maybe an info plist, or maybe just user defaults. This is up to you, and it is important to write this down, but it might not be very relevant to everybody in your team. Okay, so we have requirements, we have formalized them in Gherkin. What's next? The actual TDD bit. And I'm not going to show you actual real tests yet, because I want to talk about TDD itself for a little bit. If you've never done test-driven development before, you might not even know how that flows. So let me show you how TDD works in a nutshell. You always start with a failing test. You are not allowed to write any implementation code unless there is a failing test. This could be just trying to instantiate an object, because a failure to compile is also a failing test. Step 2, write the minimal amount of code needed to make the test pass. So if you are testing, if you can make an instance of a certain object, all you are allowed to do in this step is define the object. Don't add properties to it, don't add methods to it, just write down class myObject. Done. Test can now compile. Step 3, your test passes. Yay, you can now make an instance of your object. Step 4, rinse and repeat. So let me show you again, except now with a little bit of code. So like I mentioned, a test, try to make an object. Xcode complains, I'm not sure what a login form is. You never told me what a login form is, so I will not compile your code. Okay, fine. Go to the application, define a class, login form. Go back to your test suite, run the tests. They pass. Success. So in this case, we are testing that the login form throws an error for nil credentials. We can see that in a method name. So how do we do that? Like, what's the process? Well, let's continue. Step 4, repeat. Failing test. We are asserting that calling form.login throws an error. This will not compile because we don't even have a login method, and it most certainly does not throw an error yet. So we write the minimal amount of code needed to make this test pass. So we add a login method to the login form, and it throws an error. At this point, you're probably thinking, this is stupid. Like, this form doesn't work. Like, I know, but this is what test-driven development should be like according to the rules. So we run the tests again, they work. Next step, check that we can have a username on the form. Check that it's nil by default. Add the property, test now succeeds. Next step, password. Same thing, failing test, implementation, passing test. So at this point, we can continue this forever, of course, and we're not going to do that. What have we tested? Well, we test that we can make an instance of login form. We know that works. We also know that login form.login is a throwing method, and we know that it can throw an error. We know that a username property exists, and we know that it's nil by default, and we know that a password exists, and that's also nil by default. What's more important here is what are we not testing? We are not testing that the login form throws no error when we fill out the form correctly. We don't know that it throws a different error if I only have a username or password missing. We don't even know that we can assign a username or a password. And there's many more things. So I'm here telling you a lot about TDD, and we basically built a non-functioning login form. Just bear with me a little bit. So what do I like about test-driven development? What I really love about it is that everything you write is tested. Like everything that we just wrote works. We know that it is there. And it provides a structured way to think about coding problems. And what I also love is you cannot write untestable code because all the code you write has to be written to make a test pass. So it's all testable by default. It's decoupled. You have great architecture all the time. So what do I not like? It takes a lot of time. We just saw that just getting a simple login form that does nothing took kind of a lot of time to do. And in part, you can blame the Swift compiler because bigger projects take ages to compile. Imagine having to wait 2 minutes for Xcode to tell you, I cannot compile your code. That's frustrating. And also it feels silly to knowingly write tests that cannot pass for trivial things. So personally, I do love TDD, but I take a slightly different approach that I would like to show you today. My 4 steps are pretty much the same, except step 2 has a very minor but important difference. It is I'd still write the minimal amount of code to make the test pass, except I am writing bigger tests. So I write a failing test, but I write a lot more code. And then I make it pass. So let's see what that looks like. In this case, I wrote down, create a login form, assert that the login method throws, and check that the properties that I want to be there are there. Then I go ahead and write the minimal amount of code needed to make this test pass, except this test is much bigger, so I can now write a lot more all at once. And this test passes. The result of this is the exact same. We're still testing the same things. Login form has a login method that can throw. We can make an instance of it. It has properties, and we are not testing that it does the correct thing when it has to be done. Why I like this so much more than pure TDD is that I can now quickly add more tests, and it is no exception for me to start like, okay, I want to test that this login form throws when this is the case. I want to test that it doesn't throw when this is the case. And I'll just write 5 or 6 tests all at once, and then make them all test all at once, or in a few tries. That saves a lot of time compared to like the pure TDD, especially because, like I said, you have to wait for Swift to compile, which can take a while. So let's go to Xcode. Let's write some tests. Let's zoom in on what you just saw in terms of like how a test works a little bit more. If you've never done unit testing before, this might not be something you've ever done. File, new, unit test file. And then you get this. You get a simple class with a template from Xcode. It has a setup method, a teardown method. It has a test example method, and a test performance example method. Let's work our way up from the bottom. You see a self.measure block in that test performance example. Anything you put in self.measure, Xcode test will measure how long it takes, keep that somewhere for future reference, and every time you run your test suite, Xcode will check that this method or this code in that closure did not become significantly slower. So this is very useful if you have an algorithm that you need to be as fast as possible. You don't want to make it slower and slower over time, especially if you're not aware that something in another place of your code is now influencing this algorithm, where the algorithm itself might be fine, but the object you are passing to it is not as performant as the algorithm itself. Performance tests can help you discover this kind of things. A test example, that's just a regular old test. Setup and teardown, they do probably exactly what you might think they do. Setup runs before your tests, and teardown runs after them. So if you were to execute these empty tests, the setup method would be called, test example would be called, teardown would be called. Setup would be called again, then the performance example would be called, and then teardown would be called again. So any shared setup code or teardown code that you have, you can put in setup and teardown. So what is XCTest? It's Xcode's default framework for testing. Anybody with Xcode on their machine has access to it, and it's even part of Swift, so it should also work on Linux, for instance. You just saw that methods with the test prefix are your tests. So in this case, test example and test performance example. However, you may have also noticed that XCTest does not really lend itself to that gherkin style that we saw before. You couldn't really see, like, a given this situation, when trying to do that, then it should do this. Now let me show you another kind of test. And this one is probably a little bit harder to understand at first, but once you've read it all, it'll make more sense. So you can see here you have a method that takes a string, given a login form, blah, 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 and a context. When doing something, then it should do a certain thing. This way of testing is part of a framework called Quick. Quick is a behavior-driven development testing framework. It's very similar to what we want to do. It's slightly different, but similar enough. There are different keywords to highlight different parts of your tests, almost like the given, when, then structure that you see in Gherkin. And this makes it very suitable for this style of testing. So let's go back to that test example and let me explain in a little bit more detail what these describe context and it things are supposed to do and what you can make them do if you want to. So first is describe. In Quick, this is used to describe the system that's being tested. This would usually be describe a login form or describe a login flow. Since we don't want to do that, we want to do the TDD Gherkin kind of thing here. We have a slightly longer description here. So we say given a login form with empty credentials. And the next keyword from Quick is context. In Quick, you use this to kind of describe the conditions that the system is in. It's very similar to what the scenario or the given might be in test-driven development with Gherkin. But we can use it as a when, just because we can. So then we just write down what we are trying to do with the login form. In this case, just attempting to log in. And lastly, there's the it keyword. In Quick, it is the actual test. It is where you do all of your assertions. It is where you group that stuff together. And it's also where you would perform your actions in Quick. But you can also use it to only do assertions. And it really depends kind of on what you're trying to do exactly here. So what is important to keep in mind with taking Quick, Gherkin, testing, and putting it all in a big mix and hopefully coming out with an amazing test suite? Keep in mind that Quick was not really meant to be used, like I just demonstrated. So sometimes you will find that Quick has certain rules, like you cannot have an assertion inside of a context block. But if you want to assert that something throws an error when you call the method, then you might have to do a when, which is the action, inside of a given. So you would have to kind of be a little bit flexible with how you structure your test and how literal you take the Gherkin, but it works really well. I've used this for a while now, and it's with some shortcomings, it is the best alternative to XCTest, especially if you want to have very readable test names. So let's go ahead and implement that test that we had earlier with XCTest, where we had the login form and we assert that it throws an error. Let's see what that looks like when you pull it apart in a Gherkin style. So step one is to create the login form. It's just like we did before. Just create an instance of it. In this case, we do it in the describe block, in the given block, because that is the base setup code. The context here, like I mentioned before, you cannot do assertions inside of a context. It has to be in an it. So what I often do is if I find myself in a situation where I have to move the action that I want to perform into the assertion block, is I just write down a comment saying like, hey, I am not doing anything here because I'm testing something that needs to be asserted right away. So just accept that the code is like this. There we go. this is the assertion part. So we are just trying to log in, and we expect this to throw an error, and we can still assert that stuff is nil. Now notice that I do not have this whole xctest assert nil, xctest assert through, xctest assert throws, and that kind of stuff. I have an expect method, and I do something in there, and then I have a to be nil or to throw error. This is a small brother framework or a sibling framework of Quick, and it's called Nimble. If you love this assertions but you don't like Quick, you can just take Nimble and use assertions like these in xctest. It comes bundled with Quick though, and it makes your tests very readable. It sometimes takes a little bit of getting used to, but I really like these little assertions right there. So let's reflect a little bit on the xctest version as well. We had this test, and if you imagine that there's like a dozen of these kind of tests in your test class, it might not always be very easy to figure out what exactly is this method testing or what exactly is that method testing, because they look so similar, and reading a long method name, especially if you want to have a lot of context in it, is basically impossible. Now compare it to this, where you have a small little piece of code inside of several closures that have strings that describe what's being tested. This is almost like documentation, and this ties in really well with the stuff you did before you even get to testing, which is gathering requirements. It's very easy to take this, your requirement notes, and cross-reference them to see if everything's there. So this is all really cool if you have an empty slate, if this is your first test suite that you're building. But what if you have an existing project? What if you want to do that big refactor where you're going to write tests for your existing code base? In my opinion, it's best to go through a few phases and not go in head first. So phase one, I call the preparation phase. Simply because you cannot build an amazing test suite overnight. It takes a lot of time, and not necessarily extra time, but just it takes work, and you need to understand what you're doing, and you cannot just work late one evening and have everything under tests. What you can do is begin refactoring your code. Make small changes as you go. Find stuff that is maybe not as testable as you would like it to be and make it more testable. And then, of course, if you do have a new feature, write tests for it, because you can. So what would that preparation phase look like? Well, imagine you have code like this. You have no separation of concerns whatsoever. The URL session is used in the middle of a login form struct, which of course we never do this kind of stuff. But let's say you do have this. How do you refactor this so you can write a test? You can do something like this. Create a simple protocol for a login service. It has a single method. The login form now gets an object called login service, and it uses that instead of URL session. This is not a huge change, and I'm sure that in most code bases, changes like these can be made in a short time. And the beauty here is that this login service, because it's now a protocol, you can create a fake version of this in your tests. So if you would have the URL session version in your app, you can now make a fake network object in your test and have it return controlled responses. So you can make sure that if the network returns an error or returns a success, that it's handled appropriately. It's also tempting to go in and do everything all at once, or do like the big parts, the complicated parts, like all of your asynchronous networking code. Just don't do that. Start small. First of all, there's no point in trying to do everything all at once. But you might also want to avoid complex tests at first. You don't know how your code base lends it for all of the tests. So start simple and practice a little bit. Get a feeling for how your code base handles this, and get a feeling for how you like doing it. So I still think that the networking example is a good example of starting small. So let's look at a test that would use this fake network object I mentioned earlier. What you see here is a mock login service. And this conforms to the login service protocol. It has a login method. And in this case, we're just checking that the login form is going to call that login method. So we have a variable in there that is false at first, becomes true whenever the login is called. And then here in Quick, we can do this nifty little thing called an asynchronous assertion. You can say expect login service, and then a property that checks whether the network call has been made, and expect that to eventually be true. So if your code is asynchronous and this callback is not called immediately, your test might pass, even though the code was not completely executed. Or if you expect it to be true right away, it might not be true at that time, and your test fails, even though 0.1 seconds later it would be true. So by saying expect this to eventually be the case, Quick will hold on for a little bit. It will just wait and poll a couple of times to see if this value changes, see if this property changes its value over time. If it doesn't, the test will still fail. If it does, the test will succeed. So once you have your small tests, it's time to scale up. It's time to start tackling more complex problems. Start tackling things like multi-threading or sequences of network calls, that kind of stuff. Start expanding test cases. If you have a couple of simple cases and you're like, I'm building an email form and I have like 5 inputs that I'm testing, generate 50 random bullshit email addresses. Just do it. See what happens. Maybe your tests fail, maybe they succeed. If they succeed, great. If they fail, you have some work to do. And then start thinking about integration tests. Even though the rule says that you should never rely on things like the file system or the network when testing, sometimes you do want to make sure that your network actually works with your code. And you can build a separate test suite for this that you do not run every time locally, but just on your CI or every once in a while. So this is all really cool, and if you get to do all this, it's amazing. But it might not be easy to convince your manager. Because if you're going to start testing for the first time, you are going to need a little bit of extra time to explore testing, to explore Xcode tests, to get used to it, to get good at it as well. So how do you tell your manager that you need this time? Because if you're going to tell them that you want to study up on this for 2 or 3 days and not work on a feature, if it's a busy time, you're not going to be able to do it. To do that, I want to take a look at a login flow. Now, this flowchart might resemble something of a login flow that we have all built at some point. What it basically is just a sort of splash screen, and if you're not logged in, you're going to go to a login form. If you don't have an account yet, you can register. If you forgot your password, you can request a new password. Depending on what happens, and if everything succeeds, you either go to the main screen or back to a login screen. So there are 3 screens here that accept an email, and then the register screen maybe accepts a first name, last name. So how do you make sure that they all work? Well, maybe you have a list of inputs for email. Here I have about 9 different email addresses. There's probably a bunch more that you would want to make sure work or don't work. And you need to test that on every screen. So you need to go in, type in the email addresses, try to log in, expect a certain error to appear on the screen, repeat, repeat, repeat. And then you realize that this registration form has a name requirement. So what happens if I don't fill out a certain name? What happens if I have a period in my name? What happens if I have numbers in my name? What happens if I have 2 names? What happens if I have more than 2 names? What happens if I try to do MySQL injection attacks there? So there's many things that you would want to test there. And think for a second, like, how long would it take you to test this? All of that. Maybe 15 minutes, 10 minutes if you're a quick typer. And technically, you would have to do this every single time you are about to at least like send a build somewhere or submit a commit to your GitHub repository. So you can do better than that. And I prepared a short little video today that I think really demonstrates the difference. So on the left-hand side here, I am manually testing a login form, typing in a bunch of email addresses. And on the right-hand side, I am scrolling through my test a little bit. Build just succeeded, that's good. And the tests are already done. And yeah, the manual thing is still going. And this thing on the right, the Xcode test, it didn't test the exact same thing as the one here, because it tested way more email addresses. And that's awesome about testing with code. You're testing basically the same thing, making sure that this email address generates this input error, this other email address generates that input error. But it runs in under a second. So every time you commit, you can just, boom, run it, go. And you always know that this form is not broken. And that takes back to like what I said in the beginning of this talk, is that you don't think this login form works, you now know it works, because you've seen it work, because you have your test suite. So, how do you take this whole thing even further? Like, having tests is amazing, but you can do even better than just normal testing. In Xcode 11, we have a new feature called test plans. You can use that to test localizations. These are mostly relevant if you are doing UI tests, but it might also make sense to just try and see what happens if your code runs in an environment where Chinese, Japanese, or some non-left to right language is being used. So how does your code behave in that environment? Does it still do what it has to do? With a test plan, you can just create several plans of the same test suite that are run in a different environment. You can also use different configurations. So you can have certain debugging features on in a certain test plan and turn them off in another one. And most importantly, you can randomize test order. This might seem like it's not that big of a deal, but it's very easy, especially if you're not super experienced with testing, to accidentally have two tests that only work if they are run in a certain order. Of course, you don't want that. Every test should be able to run independent of other tests. So it's really cool to be able to say, like, I want to run my tests in alphabetical order and random order. Make a test plan for each, run them, and Xcode will do both. So your tests will be run in several different ways, and you never know what way, which forces you to write isolated tests. So if you've done this, there's one more thing that is important to do, and that is run your tests on CI. Running tests locally is great, but if you have a bigger and bigger and bigger test suite, your tests at some point, if they also have integration tests and unit tests, might start to take 10 or 15 minutes to completely run through all the tests. You're not going to do this at your desk. So what you want is to do it on every time you push to GitHub. Push code to GitHub, some CI takes that branch, checks it out, runs the tests on it, reports back to you. You can also do automated testing on set intervals. What I like to do with certain crucial parts of my code is make a secondary test suite and just have CI run the tests every couple of hours. Just in case, like if something broke because of a change in the network, or if something broke for other reasons, I will know because it sends a message to Slack. And CI, in my opinion, is the best and maybe only way to ensure that your tests are run. Humans are sometimes in a hurry, we get sloppy, we forget things, we run the wrong test suite, we don't notice that we didn't run it, we quickly ship it. So having that as a part of your whole pushing to GitHub and merging strategy, like for instance not being able to merge if CI didn't pass, is a very good way to make sure that everything is always tested. So, this was a lot. Let's summarize it real quick. When you want to write tests, you start with requirements. Even if you don't want to write tests, you should always find out what the requirements are for what you're building. If you don't do it, you're flying blind. Gherkin is a very nice way to convert requirements and conversations with people into pseudocode that can be read by everybody and contains information about what should not work, all the cases that you were testing. You can use Quick to write very readable tests if you figured that Xcode test is just not doing it for you. If you have an existing code base, begin refactoring it first, then slowly build up your test coverage and the complexity of your tests. And most importantly, testing by hand takes way more time than doing so automatically. That was it. We are out of time already, so any questions I'm happy to take outside, unless we can get a few extra minutes to do it here. I'm not sure. And otherwise, thank you very much for listening.